For this one, we're looking at the function given here, and we're told that it's not one-to-one. This graph is a shifted form of the parent function is y equals x squared or fx equals x squared. So it's a parabola. So I know it looks something like this. And this, these other parts tell me that that parent function has been shifted. That plus 4 with the x means I go left 4. So I know that this vertex, which always starts at the parent function, I should draw the parent function like this. It always starts at 0, 0. And I'll do a different color for this. This one is going to be that shifted left. So that's 1, 2, 3, 4. And the plus 2 tells me to shift down, -2. Oh, down 2. So 1, 2, 3, 4, and then 1, 2. So it's the same shape, but shifted so that the vertex is at x is -4. Remember that horizontal shift is always the opposite direction of the number with the x, and the vertical shift is always the same direction. So that's the -2. So it's a parabola with a vertex at -4, -2. So to find the domain of this, I want to use only part of this graph so that I cover the entire range, starting at y equal -2 and on to forever. But I want it to be one-to-one. So I'm only going to use the right half of this graph. So to restrict this parabola to just half a parabola, I start at the x value at that vertex, the -4. So my domain restriction is going to be x greater than or equal to -4. It can be equal to because that way we include the vertex. And that means my range will be y greater than or equal to -2. And that's the range of the original function as well, which is what I want to do. I want to preserve all those range values. So my range doesn't change. I'm really just restricting the domain. So there's my answer for part A. Now for part B, I'm asked to find the inverse and find its domain and range. Well, one shortcut here I know is that the domain and range of inverse should be just switched. So I'll double check, but it should be that my domain, it takes on this value. So those x's, the x's and y's switch. So now x's are going to be greater than or equal to -2. And the ranges the y's are going to be greater than or equal to -4. So we'll check that when we're done finding our equation, but this is what we should get. So let's not do a check just yet. Okay, so to find that inverse, I start with this original function. Except I'm going to rewrite it by switching the x's and the y's. So I'm going to start, this is the original function. And then I want to write the inverse function I'm going to switch all the x's and y's. So I have x equals y plus 4 squared minus 2. So I kind of like to draw a line on these because to separate the original function, because the x's and y's are different values now and next to each other, that confuses me. So I'm going to separate that original, and then my inverse has the x and the y's flipped, and I'm going to solve for y. So add 2 to both sides, and then take the square root of both sides. Now usually when I take the square root, I would have to put a plus and a minus, but we restricted our domain. So I know these are all going to be plus. So I'll just leave a plus there. And that equals y plus 4. And then solving for y, subtract 4 from both sides. And I get y equals x plus 2 plus 4. I just switched the sides as well, so I have y on the left. Actually, I think that's confusing, so let me undo that. So subtracting 4 from both sides, I get y equals x plus 2, and then make sure your minus 4 is not under the square root like that. You don't want that square root line to go like that. So I want to make it clear that that negative 4 is not under the square root. I'm subtracting the 4 after I've drawn the square root. So my final equation is, for the inverse, is y equals square root of x plus 2 minus 4. Now let's just make sure that our domain and range are correct, as we were hoping it would be. So this is a square root function that also starts at 0, 0, but it's been shifted left 2, so it starts at x equals negative 2, and down 4. So it looks something like that. So our domain starts at the x equals negative 2 and goes on forever. So that one is correct. Check. And the range starts at the y equal negative 4 and goes up forever. So check. So there's our final domain and range, which is just as it should have been, of the flip of the first function. And there's our inverse function.